All right. So for today, I want to go over 9.3 and 9.4. We started 9.3 last time. If you recall, we introduced what a logarithm was, and we said basically that logarithms are exponents. So if I was to take an exponential function and talk about the exponent at every turn. So for any base to the power y, if that is equal to x, that's the same as saying y is equal to log base b of x. So the domain and the range switch. Okay, we don't need to get any deeper than that. Just understand that this is logarithm form and this is exponential form. So we also talked about writing exponential equations as logarithms. So for example, if we had 8 to, since 8 is equal to 2 to the power 3, we can write that as 3 is equal to log base 2 of 8. Okay. Same thing, so log base 5 of 25 is equal to 2. So if I was to write this again, log base 10 of 0.1 is equal to -1. Okay, so if you guys can pause this anytime if you guys want to practice this on your own, but I'm just going to go through them. So log, this is the base, remember, 2 base 2 of the argument, which is 1/8, and that's equal to the exponent, which is -3rd, right? So remember the parts of the logarithm. This is the base, this is the exponent, this is the argument, right? This is the base, this is raised to the power this, and this is the argument. Okay, so if I was to rewrite this, this would be log, and then the base is a circle of a square, and that's equal to triangle. So base, exponent, answer. So base, this is the exponent, and this is the answer or solution, right? Okay, so we can similarly rewrite every log as an exponent. So I find that it's really easy to change from log to exponent because the base remains the base. And we raise it to the power x, and that's equal to 3. So we would write 2 to the x is equal to 3. Okay, can you try these next ones? You can push pause at any time and try it on your own. So base raised to the power 1 is equal to 10. So 10 to the power 1 is equal to 10, which is true. 10 to the 0 power is equal to 1. So base raised to the power 0 is equal to 1. And then again, base raised to the power 0 is equal to 1, which makes sense because any number raised to the 0 power is equal to 1 if you recall that from properties of exponents. So again here, like if we had base 1 million, we raise that to the 0 power, that would still equal to 1, right? And this is us writing log functions as exponents. Okay, so this is back and forth. Let's move on. Let's do some more super fun examples. You can try this on your own. I'll give you 5 seconds to push pause. 5, 4, 3, 2, 1. Okay, welcome back. Here is the base raised to the power 2, and that's equal to x. So 3 to the -2 is equal to x. We take the base, raise it to this power, and that's equal to 4. 8 to the x is equal to 4. So here we can take x to the power 3, and that's equal to 4. So x to the 3rd power is equal to 4. So we rewrote each log as an exponent. Okay. So some special properties of logarithms is that if you take a log of a certain base and you're taking the log of that same base, the argument is the same, and that's raised to a different exponent, that's equal to, these two are equal. And the reason being is if I was to take this and rewrite it in exponential form, okay, this would be b to the x is equal to b to the x, which is true. Since this is true, every exponent can be equal to itself. This is the same property, okay? And we're going to see that come into play in a few minutes. So say here, and similarly, if you have an exponential function that has a logarithm in the exponent and the bases match, that's also equal to the argument x is equal to x. Excuse me. And then, of course, since any number to the 0 is equal to 1. We just said this. Log of any base of 1 is equal to 0. Okay, so these are just some special properties of logs. Okay, so let's do some super fun examples using these following properties. Okay, so here I can rewrite 8 with base 2, right? Because we know that 8 is 2 to the third power, okay? So now see here, I've rewritten this logarithm as log base 2 of 2 raised to the third power. Now wait a minute, this looks like this guy, okay? See, these are matching, so this whole logarithm is actually equivalent to 3. Okay, so I simplified this and this is equal to 3. So see here, so let's say we can rewrite this, right? We can rewrite 10,000 as base 10, right? Because 10 raised to what power is equal to 10,000? And that is 4, yeah? So since I can rewrite 10,000 as 10 to the 4th, I can say that this is finally equal to 4, okay? So log base b of b, since they're the same, b has a power of 1 when there's nothing there, so this is just equal to 1. And then, of course, we said earlier that any log of 1 of any base is going to be 0. Okay, so these are some examples of using the special properties. Here's one more. So again, these two match, so it's equal to 1. So this is actually log 4 of 1. And then again, since any base, if you find the log of 1, that's also equal to 0. So finally, this whole what looks kind of confusing is actually pretty simple because you work from inwards out. Okay? So you can replay this as many times as you like. So that's that. Let's move on to even more fun examples. Okay, so let's write these in logarithmic forms. So this is log base 3 of 9 is equal to 2, right? And I'll let you guys practice this. You can push, let's push pause, and I'll give you whatever. You can push pause until you guys are ready to see them, okay? So let's pause this, unpause, and let's see if we can, if our answers match, right? Base 4 of 2, the exponent is 2, of 16 is equal to 2, right? Log base 4 of the argument, which is 1 over 16, is equal to the exponent, which is negative 2. Log base 1/3 of the argument, which is 9, is equal to the exponent, which is negative 2. Okay, and then we know how to write these in exponent form. You guys can pause the thing. I'll give you 5 seconds to pause this so you guys can practice it on your own. Honor system, okay? 5, 4, 3, 2, 1. Let's go ahead and pause it. Okay, and is that the answers that let's check your answers. Did you get 2 to the 3 is equal to 8, 2 to the 5 is equal to 32, 10 to the negative 4 is equal to 0.0001, excuse me. And remember, 7 to the power 2 is equal to 49. A lot of these numerical answers are pretty easy to check, right? When they're simple like that, because if you get something like 7 to the 49th power is equal to 2, we know that's obviously false. So we know we wrote something incorrectly, okay? Great. Let's move on. We can use these properties to solve for x now, okay? So let's say we want to know when log base 4 is equal to 3, okay? What value of x is this logarithmic function equal to 3? So we can rewrite this, okay? We rewrite this in exponential form, and we get that 4 to the 3rd power is equal to x. In other words, 64 times 4, which is what? 64 times 4. 256. So x is equal to 256. And then here we get 2 to the negative 4 is equal to x. So x is equal to 2 to the negative 4, which is 1 over 16. Okay. Now here, the x is on the outside. So we observe that these two have common base. I can rewrite 27 as 3 to the 3rd power. So observe. Now, because of property of logs, this all cancels out and this comes down. So x is equal to 3. Okay. So you got to use the property of logs. Okay, so here you have 25 and 5. They kind of look similar, but they don't, right? You can do this one of two ways. You can notice that 25, the square root of 25 is 5, yeah? So 25 to the half power is equal to 5, okay? So one way you could say this is like, okay, I can rewrite this in exponential form, or I can replace this with this 5 with square root of 25. So log 25 of 25 to the half power is equal to x, since this is true. Okay, so that cancels and you get x is equal 1/2. Okay, another way you could have done this, so just in case you were like, well, I don't remember that, you could have written this in exponential form, but you come to the same conclusion anyway. So you would have written 25x is to the half. Well, we know that 25 is 5 squared. And then you get, these cancel out because they're the same base. 2x is equal to 1, x is equal to 1/2. So there's more than one way to do this problem, okay? All right, here we have x to the 4th power is equal to 16. Sorry. So x to the 4th power is equal to 16. You can take the 4th root of both sides, and then you get the 4th root of 16 is just 2. So x is equal to 2, right? And you can either plug this in your calculator, or you could observe that 16 is the same as 2 to the 4th power, and these cancel out, and that's how you get 2. So here is the homework assignment for 9.3. You can go ahead and pause this now. I'll give you 5 seconds, and I'm going to move on to section 9.4, okay? So 1, 2, 3, 4, 5. Okay, we're going to move on to, ta-da, properties of logs. So first property we have is called the product property. And simply put, it's this. If you take the log of base b, any base, of the product of two numbers or two variables, whatever, you can rewrite or expand that log in terms of these factors. So saying the log of base b of xy is equivalent to saying log of base b of x plus log base b of y. So this multiplication can be expanded into two different logarithms separated by a plus sign. Okay. Well, so let's do some examples. Okay, so example number 1, you have here log base 3 of 5x. We can rewrite that as log base 3 of 5 plus log base 3 of x. Okay. So that's one. So you guys can start kind of seeing what this next one's going to become. So log base 4 of AB is going to be log base 4 of A plus log base 4 of B. Okay. So common log is base 10. So in the book, it doesn't really talk about this too much, but I just thought it would be worth a mention that if there is not a log written down here, it's assumed to be base 10. Okay, in the book they actually write out the 10, but in the in the normal math world you don't really write that 10 out. It's kind of like how 1 is in front of the x. You see x, you assume that there's a 1 in front of it. That's kind of what this is. This is called a common log. So anyway, this is log of the product xy. And we will rewrite this as log of x plus log of y, knowing that since there's nothing here, it's base 10. Okay. So I'm just going to use them interchangeably, so just don't get confused if you don't see a base. That just means that I assume it's 10. So now you guys try this. Okay, now you try. I'm going to give you 5 seconds to push pause here. And I really want you guys to try this one. My hint is that it's a product of 3 things here. So, okay. So you have 5 seconds to press pause. 1, 2, 3, 4, 5, and unpause. And did you get the following? Since this is a product of 3, x, and y, you would get log of 3 plus log of x plus log of y. So again, I've expanded this. I'm expanding this simple logarithm into 3 parts, okay? Because there are 3 factors. 3 is a factor, x is a factor, y is a factor, okay? Okay, great. So let's move on. Not right now. Okay, so now we're going to go to the next property, which is the quotient property. So you have if you have a log with a base b and it's a quotient written as a quotient x over y. So if you think that for a product of log you would expand it using a plus sign, for the quotient of a log, what do you guys think we're going to expand it using? We're going to expand it using a minus sign. So it's going to be the difference between the numerator and the denominator, okay? So let's do an example. So let's say, suppose you have log base 3 of 5 over x. You can rewrite that as log base 3 of 5 minus the denominator, which is log base 3 of x. Okay, so let's try the second one. So log, this is an invisible base 10, okay? So log of base b of, log of b over x can be written as log of b minus log of x. Okay, so now this one here, we combine the properties because see you have a product of 5 and x in the numerator and a y in the denominator. And I'm going to show you guys a short way of thinking about this when you have like a fraction. Basically, because of the properties of log, everything that's in the numerator is going to be positive or have a plus sign in front of it, and everything in the denominator will be negative, have a negative sign in front of it. Okay, so essentially we can expand this as log base a of 5 plus log base a of x minus log base a of y. So see, these two are positive, they're in the numerator, and they're products of each other, and this is a negative, it's in the denominator, okay? So let's see if you guys can try this one. You can take 5 seconds or whatever, or pause this and try it on your own. But basically you would have log base b of a plus log base b of b. Well, this needs to be 1 actually. So log base b of c minus log base b of d. And remember this is equal to 1 because this and this match. So you would have log base b of a plus, minus log base b of c minus log base b of d plus 1, because this is a 1 here, okay? So that's what you would have. Okay, so now you try this, guys. Please take like 1 minute. Or okay, so I'm sure you guys are all trying this now. And boom, is that what you got? Check your answer. You should have log base 5 of 3 plus log base 5 of x plus log base 5 of y minus log base 5 of z, which is in the denominator. Remember, the denominator is negative. Okay, let's move on to the last property, I believe, that we're going to cover today, which is the power property. Definitely a favorite. So any log that you have here of any base b, of some letter, variable, number, whatever, if they have a power of, let's say, of r, you can rewrite this logarithm by simply taking this power and moving it to the front, and it can be rewritten as r log base b of x, okay? So let's do some examples so you can see what I'm talking about. So let's say, for instance, here we have log base 5 of x squared. This squared can be rewritten in the front, and we can rewrite this as 2 log base 5 of x, which is really a cool property of the logarithm. So let's say here you have log base 2 of x raised to the y power. So we can think of this as y log base 2 of x. Okay. Now here we have log of the square root of y. And I'm sure you guys remember that the square root is the same as raised to the half power. So this can be rewritten as half log of y. Okay. So again, here you have two of them, okay? You have two. Well, these two are products of each other. This whole product is not raised to one single power. This is a product of two different variables raised to two different powers. So we can use the product property first, okay? So this is log of a cubed plus log of b to the 5th power. And now we use power property. We can rewrite this as 3 log of a plus 5 log of b, and that is the most expanded form. When we cannot do anything more to the log, we can't expand it any further, we leave it as is. That's the most expanded. Okay, so now you guys try. This is log base 2 of x to the 4th over the square root of y times z cubed. Okay, so I'll give you guys 10 seconds to push pause, and then I will write the solution, and then you guys can go over it. Okay, are you guys ready? Are you ready? Here's my first step. My first step is I rewrote this as the numerators being positive and the denominators being negative. I used power and quotient properties first. So this is x to the 4th on top, which is positive. And this is a log square root of y. They're all base 2, mind you. This is a negative. And then you have minus log base 2 of z cubed. Now, am I done here? I'm not done here, right? Because I can continue to simplify, expand rather. And I can rewrite this as 4 log base 2 of x minus, remember that the radical is a half power, so this is half log base 2 of y minus. And then this 3 comes in front, and that's log base 2 of z. And now we have fully expanded it, and we're done, okay? So you can take 2 steps to solve this type of problem. All right, we're almost done, guys. Okay, last few examples. Well, I have like 3 more slides for you. You can use the properties in reverse, okay? When you use the properties in reverse, let's say you have a sum or a take the puppy out. Sorry, guys. Okay, okay, here we go. Now we can rewrite this as a single logarithm. So when we're going from expanded form to condensed form, we need to, first you can use your power, we need to use the power property first, because we need to write this as the product or see this as the product and quotient of logs. We can't do that until we have 1 in front of each log, okay? So we need to first start by moving each one of these terms, each of these coefficients to the top of the variable, okay? So this would be rewritten as log base base 10, of course, of a squared plus log base 10 of b cubed minus log c to the 1/3 power, okay? Now that we have written in this way, we can rewrite this as a quotient. Remember, the positive ones go in the numerator and the negative logs go in the denominator. We can condense this, right, as a single log, okay? So this is a squared b cubed all over c to the 1/3 power, okay? And that's your answer, okay? So let's do another example. Sorry, hold on a second. Okay, so we continue. We're going to use the power property, and we write this as log base of x to the 1/3 minus log of y to the 1/4. And then we can rewrite that as a quotient, log x to the 1/3 power over y to the 1/4. Okay, so we condensed this. We rewrote this as a single logarithm. Okay, so now we're going to use the condensed, write this expanded log in condensed form in order to solve for x. And let's do that. So since this is a plus, we can rewrite this as log 2 of x plus 2 times x, and that's equal to 3, okay? So we condense this log. But now, how do we get x by itself? Well, if you recall from the beginning, 9.3, we can rewrite any logarithm as in exponential form. So let's do that. So this is base 2 raised to the power 3 of this product. In other words, 2 cubed is equal to x plus 2 times x. Okay, so now look, we've eliminated the logarithm completely. So let's distribute. We have this 2 cubed is just 8, and that's equal to x squared plus 2x, subtracting 8, because we want to solve for x, right? We have 0 is equal to x squared plus 2x minus 8. Now remember the diamond method, negative 8, 2. What are the factors of 8? Of negative 8 that when added together give you positive 2, so that's 4 and 2. So 0 is equal to x plus 4x minus 2, okay? And so your values of x can either be negative 4 and positive 2. And we have an extra solution because one property of logs that I omitted to mention, and I'm mentioning this now, is that you can never take the logarithm of a negative number. So log of negative 4 does not exist. We can't do that. That's because the logarithm function looks like this. See, it's never negative. It's never negative. So we can't very well take the log of a negative. It doesn't exist. So your x has to be 2. Okay. All right. So then I have some homework examples, and this section is optional, but I would like for you guys to try these. Okay. Try these on your own, and I'll show you the solution in about 10 seconds, okay? Okay, here are the solutions for the first 4 of these problems, and this last problem, I want to go through it together because there's a couple ways to do this. For this number 12, you could rewrite this this 1/3 as the exponent 1/3, and then distribute that exponent, which gives you x to the 1/3 power. 6 times 1/3 is 2, right? And then go ahead and expand it. Then write the exponents to the front, and then you're done. But in this case, I'm going to try a different approach. This is the log of base b of x to the 4th y cubed over z to the 5th. All of this is raised to the 1/4 power, so I'm going to do product property first. Okay, so this is essentially 1/4 log b of all of this business. Okay, and now I'm going to expand this, but I'm going to remember that I have a 1/4 in front of everything. So I'm going to rewrite this as 1/4, and then I'm going to go ahead and expand all of this. So this is log b x to the 4th plus log base b of y cubed minus log base b of z to the 5th. So see, since I'm expanding just this part, I leave the 1/4 outside in parentheses, and then I'm going to distribute it at the end. So now I can use power property. And I have here 1/4 times 4 log b of x plus 3 log base b of y minus 5 log base b of z. And I'm just going to distribute that 1/4. 4 times 1/4 is just going to be 1, so log base b of x plus 3 times 1/4 is 3/4 log base b of y minus 5/4 log base b of z. And that is your final answer. This b actually should be smaller, so let's make it smaller. Okay, great. Okay, so last final page you guys have here. So I'm going to give you guys a few seconds to try this out on your own. These are homework problems. Okay, so go ahead and try that. And And then when you're ready to check your answers, you can go ahead and unpause. So I did the first two for you. I said log, since it's a minus, we're writing as a single logarithm, so we're working backwards. It's x over z. The positive is in the numerator, the negative is in the denominator. And then here, these you use power property first, and then you can go ahead and rewrite it as a single logarithm. The positive ones being in the numerator and the negative logs being in the denominator as seen here. Let's do one together. So for number 34, I'm going to go ahead and use power property first. So observe, I have here log, this is base 10, right? The problem had written it out, but I don't need to. So log base 10 of y to the 4/3 power minus log base 10 of z to the 5th power. So now we can rewrite that as a single logarithm, log of x cubed all over y to the 4/3, oops, sorry, 4/3, z to the 5th power, and that's my final answer, okay? This, just to make sure you guys can see. Okay, log to the 4th, here, this is a 4/3. Sorry if it looks messy. Let me fix that. This is a 4/3, okay. So then the last two problems, you can rewrite this as a single logarithm on the left-hand side and then use exponential, like change it to an exponential function and then solve it. So this is going to be log base 3 of 2x, right? Because this is 2 times x is equal to 2. So rewriting that as an exponent, 3 squared is equal to 2x. So you have 2x is equal to 9, x is equal to 9 over 2, okay? So that's this one. And then here, same thing here. So x times 6, the square root of x times square root of 6x plus 5. Well, that's just x times 6x plus 5. That's the square root of all of that. Okay? So log base 2 of this is equal to 1. So 2 to the first power is equal to this. So in other words, you get square root of x times 6x plus 5 is equal to 2. And then you can square both sides. This is just a 2. So this is, and then distribute this since I'm running out of space. 6x squared plus 5x is equal to 4. So subtracting, I'm going to write this here, 6x squared plus 5x minus 4 is equal to 0. And then I'm not sure if this is factorable. Give me a second. 2x and 3x and plus 4 minus 1. So that would give you 8x minus 3. So you could do reverse box method to factor this. I don't have space, but you guys can go ahead and do it. And you would get x is equal to 1/2. And x is equal to negative 4/3. And negative 4/3 would give us an extraneous answer, so you cancel that out. So you're left with x is equal to 1/2, okay? And that's number 48, which is actually not part of our homework, but anyway, your homework is 1 through 47 odd, okay? And for the rest of the class period, I would really like for you guys to I'm going to ask that you guys go ahead and start working on the homework together. You can WhatsApp me. I will have it on me, I think, hopefully. I may or may not be available. I'm not sure. Actually, we're doing a bunch of family stuff, but you can try to WhatsApp me or email me, and I can check my emails. And your other homework was this. Remember, 9.3, 1 through 35, and 45 through 55 odd. So I really want you guys to work on this together during the class. And, you can check your answers in the back. And then on Wednesday, we're going to start our review for the final. And I think that's everything I have for you guys. So enjoy your day, and I will see you guys on Wednesday. So please make sure that you have completed, or at least are close to completing the assignment. I'm sure you guys at least have like 20 to 30 minutes, hopefully, to finish it. Okay, thank you very much. I'll see you guys then. Bye.